Hello, welcome to the first video in this lecture video series. In this series, I will be going through the concepts and the methodology of designing experiments in a way that adheres to the scientific method. The scientific method, put simply, is the method followed by scientists and researchers where they suspect something to be true and they lack an existing physical or mechanistic result to prove it. So, they resort to collecting a sample of data and analyzing it to validate their presumptions. This course aims to showcase the benefits of conducting well-designed experiments as a means to collect data in order to answer a research question or gain knowledge about a process or system of interest. In this introductory video, I would like to introduce the topic as well as explain the need and the advantages of applying the methods learned from this course when designing experiments. Now, before formally defining what an experiment is, as well as what it means to design it, let us remind ourselves of what a process is. A process can be thought of to be a one or more sequential steps that result in the change of some inputs to eventually obtain an output or an end result. Regardless of its complexity, each process will have at least one factor that can be controlled by the person or persons responsible for it. These factors can be referred to as inputs, parameters, or the independent variables of the process. The levels at which each input is set will control the nature of the process's output. The output might also be referred to as the response or the dependent variable of the process. Note that a process can have multiple responses or multiple dependent variables that are of interest. The people interested in a particular process may be interested in learning more about the relationship between the inputs and the outputs of the process. That is, their goal is to build a mathematical model that will establish a cause and effect relationship between the two sides of the process. A mathematical model will in turn help them to distinguish between the inputs that greatly influence the response from those that do not have that significant of an effect. As are most cases, the process owners will lack a physical model that can describe the exact or true relationship between the inputs and the outputs. Therefore, they are left with no alternative other than to build an empirical model to approximate this relationship. So how does the designing of experiments play a role in all of this? Well, in order to build an empirical model, or a model that does not rely on a physical or mechanistic phenomena, you will have to resort to the process itself and obtain realizations of the response that you're interested in studying. In other words, you'll have to collect data and then use this data to build the model. Now, data collection can be done using several methods, the most notable of which are through historical records, passive observation of the process, simulating your process using a computer, or conducting physical experiments. Now, these methods are all used in practice, and as such, there is no one method to rule them all. Each of these methods have benefits as well as drawbacks. For instance, relying on historical data is easy if it's readily available, but the data might be outdated, and as such, it will be an inadequate way to represent the process in its current state. And while the method of passive observation of the process in its current state does not suffer from this, it does not allow us to answer any what-if questions, since it only grants realizations of the process in its current state. In other words, it does not allow us to perform predictive data analysis, which is something process owners are usually interested in doing. On the other hand, if you're willing to, and are able to build a computer model to simulate your process digitally, you could hope to perform some predictions that way. But if you were to try that, you will soon find out that it's not easy because there is a limit on the level of complexity that can be incorporated in a simulation model. Even if the simulation model is built correctly, it will be based on probabilistic models that will fail to provide the same knowledge about your process that you would be granted by conducting physical experiments. Now, running experiments can be time-consuming and expensive in many cases. It can also be intrusive, which means that if you're studying a process that already exists and is running, you will have to disrupt the process. For instance, if you're studying the effect of changing some parameters on the yield of an existing production line, you will have to stop that line to change the parameters and see the effect on the yield. This is why it's important to design an experiment. The effective designing of experiments allows experimenters to accommodate the physical and economic constraints of conducting them. So it is important to keep in mind that experiments are a data collection method that allows the experimenter to gain information that exceeds other common data collection methods. The clever design of these experiments allows the experimenter to build empirical models with desirable statistical properties and at a reduced cost. This course aims to showcase the methods and guidelines of how to conduct well-designed experiments in order to obtain a model that will adequately describe a process. So in this course, we will cover the important characteristics of the process or system that you wish to study and how these characteristics shape your design selection as an experimenter. We will also cover many types of experimental designs that exist, and we will learn about the different scenarios where different designs can be used. In some cases, there will be more than one design that can be implemented to carry out an experiment for a single scenario, and we will learn how to evaluate these candidate designs to select the one that more closely fits the experimenter's objectives. Lastly, we will cover the post-experimental steps that include fitting a model to the data collected from the experiment, as well as analyzing that model. That is all for this video. Thanks for watching, and I will catch you in the next one.